This is another problem I have with theoretical physics. I'm just looking through David Tong's lecture notes on general relativity at the moment, and it starts off with this section on page 144. It's no fun carrying around a morass of fundamental constants in all our equations. For this reason, we often work in natural units in which various constants are set equal to 1. From now on, we will set c equals to 1. Any other choice of c, including 3 times 10 to the 8, is simply dumb. This means that units of length and time are equated. However, different communities have different conventions when it comes to g. Relativists will typically set g equals to 1. Since we've already set c equals to 1, we will have brackets g equals lm to the minus 1, setting g equals 1, then equates mass with length. This is useful when discussing gravitational phenomena where the mass is often directly related to the length. For example, the Schwarzschild radius of a black hole is rs equals 2gm over c squared, which becomes simply rs equals 2m once we set g equals to c equals to 1. Yeah, well, it is the Schwarzschild radius of a black hole is the first equation, it's not the second equation. Why are you setting it equal to 1? Why are you meddling with fundamental constants? I don't understand this so much. Like, g and c are not equal to one another. They don't equal 1. It's like fine, like, this is the problem. It becomes abstract. This is a mathematical abstraction. And you say, oh, it's just convenience, it's just convention. Like, okay, well, fine. If you're having so much fun with your equations, so much fun just jumbling fundamental constants around, like, they're after all fundamental constants of nature. We can't just go around saying that they're equal to one another. The speed of light is a very important fundamental constant. I don't care about, like, your conventions or what makes it more fun for you to mess around with equations with. I mean, for everyone else, this is a really big problem, particularly if you're trying to deal with things like the speed of light and gravitational forces at the quantum level, if you see what I mean. And equating mass equal to length, well, the mass of something isn't always equal to the length of something. Or the mass isn't, like, well, what does he exactly say? This is useful when discussing gravitational phenomena where the mass is often directly related to the length. Yeah, well, often, sure. Not always, though. If you're looking for, like, new theories of fundamental physics, and you're wanting things like theories of everything and theories of quantum gravity, then we've got to deal with, like, every gravitational phenomena conceivable at the quantum scale and applied to the macroscopic universe. Since Einstein's field equations deal with pretty much everything in the observable universe that we're aware of, from black holes to stars, planets, galaxies, everything else like this, well, it doesn't really deal with galaxies so well because it doesn't integrate dark matter into it, and we need that bolted into general theory of relativity. We need, like, this lambda CDM model of cosmology and so on. This, like, lambda, cosmological constant and cold dark matter theory to make cosmological models work, to make galactic astrophysics work, and these sorts of notions. We haven't detected dark matter yet, and it's still, of course, an outstanding problem. But g equals to c equals to 1, like, they are not equal to one another. They cannot both equal 1. If you want some other, like, convention for it, I think it's dumb to say, like, to use the actual values of the fundamental constants. Isn't it more like a challenge to use the fundamental constants and to really use those and integrate them into your equations? And yes, to have to memorize some goddamn numbers. I mean, memorizing the gravitational constant isn't that hard. It's 6.67. I can't remember it. Times 10 to the minus 11, isn't it? And c is obviously the speed of light, 300 million meters per second. 3 times 10 to the 8 meters per second. It better be fucking meters per second, not. It's not kilometers per second. No, it's meters per second. Yes, I was right. So, like, it's an issue, isn't it? This sort of thing, how we understand general relativity, how we teach general relativity. And then, like, all this teaching of it, all this natural unit stuff, so-called natural units. They're not natural units at all. Those are unnatural units. It totally skews it. You're just like, oh, but this makes it easier. Like, well, like, or just assuming that fundamental constants, which, I mean, big G, that is in Einstein's field equations, that's still very important to the field equations, as is obviously C. And, well, don't really have... It lacks physicality then. That's the point where you stop doing physics and you start doing applied or even pure mathematics, for all I know. Really, yeah, like ostensibly applied mathematics. But what does it apply to when G equals C equals to 1? It might you get dinky little formulas out of it where you get, which becomes simply R subscript S 2n once we set G equals C equals to 1, which isn't really the Schwarzschild radius, or isn't really the formula for the Schwarzschild radius. Since the Schwarzschild radius formula is R to the R under S equals 2 GM over C squared, where the constants are not equal to 1. I hate physics. I hate it. I hate this sort of thing. I have to wade through research papers suspecting actually things like this, that they're using natural units or whatever, or so on and so forth, to say, this to this and this over this and and this over the Poincaré group and whatnot, and like the fucking Poincaré group. What next? What more mathematics is it going to be? I sympathise with Ed Copeland, who on a YouTube channel on 60 Symbols once said, it'll be 500 years before we have a theory of quantum gravity. He said in a sort of wry way, sort of just smirking a little bit and saying he's one of these people who just plumps for string theory, because it's probably bullshit, but it's good enough bullshit to teach, and it's a very fun idea. It's a brilliant idea. What are cosmic strings but magnetic field lines? Let's face it. What's a magnetic field line but a photon fluid passing through something? It's all condensed, bound up very tight, but a photon fluid, going through matter at light speed, or very quickly from the supermassive black hole at the centre of the galaxy. I guess supermassive black holes have magnetic fields, do they not? So that's what a cosmic string would be. And yeah, you can probably fish something out of experiment eventually and find something that would line up to observation pretty much nice and neatly. But this can't continue, this sort of thing in physics. This teaching of natural units and mathematical abstraction, going off into math world, where this can equal to this can equal to this, because Poincaré, so on and so forth. It's we need to actually know what is really happening, what is really going on, in terms actually not of equations, in terms of diagrams, which is what Penrose, I believe, said back in the 60s and 70s. No more equations, and this is just being fished out of that Hawking made-for-TV movies. We use diagrams instead. Feynman used diagrams eventually, instead of all the mathematics. And, just eventually, instead of this constant need to mathematise, and I don't know what it is, to play around with equations and have fun with them. They're not supposed to be fun. They're supposed to be very serious endeavours, underpinned by very serious and careful thinking about nature, and yes, incorporating the fundamental constants, which are fundamental, by the way. Not they're not supposed to equal 1. They're certainly not supposed to equal one another. That seems like charlatanry to me. That seems like sophistry and illusion and nothing more. It's like what David Hume said, you can commit all this stuff to the flames because it produces no measurable quantity of phenomena in nature, or words to that effect. Right? You can commit it to the flames, for it contains nothing but sophistry and illusion. Think of that, sophistry and illusion in physics. It's one thing to say that the Schwarzschild radius of the black hole is R subscript S equals GM squared over C squared. That is not that, is it? No, 2GM, sorry, over C squared. using the fundamental constants G and C, that's one thing. I'm happy with that. That's fine. Things like the speed of light have been proven, obviously, in experiment for hundreds of years. I'm not going to go arguing with that sort of thing. But this sort of thing with natural units, we'll just put it like, we'll just put it all equal to 1. That's fine. It's fine. We just use it all equal to 1. No, it isn't. Well, I'm dumb, am I, for thinking that? And you say at the beginning of the article, David Tong, we're going to start doing physics now. I was like, you're not doing physics at all. This is no longer physics. This is some sort of bizarre mathematics. This is no longer physics. You're just kind of like derivations and like, because this. In maths, it makes sense in maths. Well, let's get out of math land and actually start doing physics with real physical constants. And let's start measuring real physical quantities and testing using those to parameterize our assumptions, gauge things that are happening in real reality, not in abstract math land. I hate physics because of this. It's stupidity is what it is. It's nonsense. It's a waste of fucking time. You're wasting other people's time as well and mine. Yeah, and you're wasting the time of your students. You're wasting the time of the public. You should be cracking on and doing real physics about the real physical world and gaining physical insight and intuition rather than spreading this garbage around.